reporting from the TECE Research Laboratory. Today we have prepared 2 experiments to shed light on the topic of leakage water at shower channels. The waterproofing standard, DIN 18195, requires leakage water drainage and secondary drainage solutions to drain additional waterproofing layers. This standard originated at a time when bathrooms were sealed only by a layer of bitumen below the screed. This standard did not take into consideration the composite sealing solutions used today. Some construction experts are now demanding that the principle of secondary drainage should also be applied to modern thin bed sealing. This would see water that is leaked below the tiled floor being drained via an open joint near the shower channel. We want to investigate if water would actually flow, in this case below the tiles, by carrying out an experiment. The experiment setup. For our experiment, we have fitted a shower channel to each of 2 trays. After they have been properly sealed, the tiles were laid using the thin bed method. We have used glass tiles. This makes it possible to see what is actually happening below the tiles. For this experiment, we installed a continuous closed channel body in the first tray. In other words, a shower channel without secondary drainage. The tiles were laid with a standard joint and grouted to meet wet room requirements. The joint between the channel body and tiles is sealed with silicone. In the second tray, we used a shower channel without an upstand. This was installed leaving an open joint at the shower channel. Leaked water should drain into the shower channel via this joint. Consequently, the shower channel has integrated openings to drain leakage water. For our experiment, we have filled 3 watering cans with colored water. The first experiment begins. Let the water pour. The water flows over the tiles and into the channel body. Due to the length of the shower channel, water begins to build up in the channel body while draining, before flowing into the floor drain below the channel. At first sight, it is not possible to detect any water leaking below the tiles. Our yellow-green water is fluorescent. This enables us to detect even the smallest leaks using blacklight. As you can see, there is nothing to see. Practically nothing can leak through the joints and the continuous closed channel body into the ground below. Over time, the joints can begin to crack apart. What happens then? Okay, we will just have to lend a hand. Pass the hammer, please. Using a hammer and screwdriver, we destroy one of the joints. Now, that is done for. We repeat the experiment with water from the watering can. And again, there is no water flow to be observed. Despite having destroyed the joint, no serious water inflow occurs. The modified grouting material is designed to ensure that only minute quantities of water are able to permeate. In addition, modern joints are not vapor retarding. That means that moisture cannot drain into the ground below. However, it can permeate through the joint into the air to dry. And that also becomes clear under blacklight. There is no water inflow despite having destroyed the joint. What happens now with our channel with the leakage water openings? Let us repeat the experiment. Again, water flows over the tiles and into the channel. However, in this case, the secondary drainage develops a totally unexpected effect. When the water builds up in the channel, it rises up to the tile level. And this is where something totally surprising happens. Waste shower water flows through the openings, which are there to allow the water to drain away, and is sucked directly under the tiles. This is where the phenomenon known as the capillary action takes over. The moisture penetrates several centimeters into the mortar bed. Even worse than the moisture in this case is the contamination that results from the waste shower water penetrating below the tiles. Let us take another look with the black light to make this clear. Just imagine, the green fluorescent liquid is in reality a mixture of waste shower water, soap, flakes of skin, and hair. Microbiological decomposition processes in places such as these can quickly lead to hygiene problems and unpleasant odors. Conclusion. Today's grouting material is so good that only minimal quantities of water are able to ingress through the joints. And these quantities of water are dried when passing through the joints. Of course, it is not possible to guarantee that the joints and the tiles will remain 100% sealed over the lifetime of a shower. Consequently, it is imperative to install a sealing layer below the tile adhesive. Following these experiments, it should be noted that, number 1, the quantity of water able to ingress through deteriorated joints or not completely watertight tiles is certainly less than the quantity of water drawn under the tiles via the leakage water openings. Number 2, leakage water openings in the shower channel do not drain the water. On the contrary, they distribute the water below the tiles, solutions that can appear sensible when tiling patios and other outdoor surfaces can lead to problems with floor-level showers. No matter what design of shower channel is used, it is imperative to ensure that openings and cavities where the channel is installed are permanently sealed.